Hello everyone, today we're going to be working on problem 2-40, and this problem is asking us to determine the magnitude of the resulting force and its direction measured counterclockwise from the positive x-axis. So with our figure given here, we have our y-axis, we have our x-axis, and we have our two forces, F of 1 and F of 2. So to start this problem off, what I like doing is I like finding the horizontal and vertical components of each force. So I'm going to start off by finding the horizontal components of each of them. So F of 1 of x. So to start off, what I like doing is I like drawing a triangle like that. And as you could tell, this is our y-axis, this is our x-axis. So they make a 90-degree angle. And since we know that this angle right here is 45, we know that this angle right here is also going to be 45 degrees. So from there, what we know that the hypotenuse side of this triangle right here, this is the triangle that we're looking at. We know that the hypotenuse side of it is 200 newtons, and we are trying to find the horizontal component, which is along the x-axis. So we're trying to find the adjacent side, and we are given the hypotenuse side. So since we know that, we could do 200 newtons times cosine of 45, since we know that cosine is adjacent over hypotenuse. So we input that into our calculator, and you want to make sure that your calculator is in degrees. So 200 times cosine 45 is 141.42 newtons. So now we're going to move on to f of 2 of x. And f of 2 of x is 150 newtons. And then from here, we draw this triangle right here. So we are trying to find this angle right here, the one that goes along the x-axis. And once again, we know the hypotenuse side of it, we know the adjacent side to this corresponding angle. So once again, we should use cosine. So 150 newtons times cosine of 30 degrees. So 150 newtons times cosine of 30 degrees is 129.90 newtons. And like that, we were able to find our horizontal components of each vector. So now what we're going to do is we're going to find our vertical components to each vector, to each force. So from here, we're going to start off again with f of 1. So f of 1 of y, since we're trying to find the vertical component of it now. So we have 200 newtons times, and this time we're going to use sine instead of cosine, since we are trying to find, so once again, this is our triangle right here. We know that this angle is 45, since this full angle has to be 90 degrees. So this time we're trying to find the opposite side corresponding to this angle right here, and we know the hypotenuse side, and sine is opposite over hypotenuse, so we could use sine this time. So sine of 45 degrees. And if we plug that into our calculator, we should be getting 141.42 newtons. From there, we could do f of 2 of y. we have 150 newtons. And then from there, once again, we are given the hypotenuse side, and we're trying to find the opposite side, which corresponding to this 30 degrees. So that's why, once again, if you use sines, so sine of 30 degrees. So 150 times sine of 30 equals 75 degrees. I mean 75 newtons. So now that we found our horizontal and vertical components to each force, what we're going to do is now we're going to try to find the net for the horizontal and our vertical components. So now, oh, we forgot to do one thing. So now that we found the forces to each of them in horizontal and vertical components, now we have to find the direction that it's going in. So if we were to take a look at this given figure, and we know that this is our y-axis, this is our x-axis, correct? So let's start off with our vertical components. This way, y is going upwards, and this is y going downwards, and this is x going to the right, and this is x going to the left. So by knowing that, our vertical components has to be in going up or down. So let's take a look at f of 1. F of 1, as you can see, is going upwards in this direction, which is why the 141.42 newtons is going upwards. And then for our f of 2, you could see that it is also going upwards. So which is why the 75 newtons is also going upwards. From there, for our horizontal components, we're going to try to see if it's going right or left. So for f of 1, we could see how it is going slanted towards the right. So the 141.42 newtons is going to the right. And then for our f of 2, we could see how it's going towards the left, right here. So that's why the 129.90 newtons is going to the left. From there, we're going to try to find the net horizontal and net vertical. So we're going to assume that we're going to do first horizontal. So we're going to assume that going right is positive. So from there, we have 141.42 newtons going to the right. That means that's positive. So positive 141.42 newtons. And then from there, we have 129.90 newtons going to the left. That means they're negative. So minus 129.90 newtons. And then from there, we input that into our calculator. And you should be getting 11.52 newtons going to the right. From there, we're going to do the same thing for our vertical. We're going to assume that going upwards is positive. So f of r of y. From there, we have 141.42 newtons going upwards, so that's positive. And then once again, we have 75 newtons going upwards. So again, that's positive. So plus the 75 newtons. So if you sum that up, that should give you 216.42 newtons going upwards. So now that we found our net horizontal and net vertical, from here, what we're going to do is we're going to sketch it out to help us determine the magnitude of our resultant force. So we're going to draw our y-axis and our x-axis. So from here, we have that for our horizontal components, we have 11.52 newtons going to the right. So from our x-axis, we have 11.52 newtons going to the right. And from there, for our vertical components, we have 216.42 newtons going upwards. So 216.42 newtons going upward. And our resultant force will then be in this quadrant right here. So to find our magnitude for our resultant force, we do F of R is equal to the square root of 11.52 squared plus 216.42 squared. So we input that into our calculator. 11.52 squared plus 216.42 squared, and that should give you a magnitude of 216.73 newtons. And just like that, we were able to find the first answer to our problem, which was asking us to determine the magnitude of the resultant force. So that is our magnitude of our resultant force. Now for the second part, it is asking us to find its direction measured counterclockwise from the positive x-axis. So what it's asking us to do is from the positive x-axis, so this side, we are going to be going counterclockwise until we hit that resultant force. So that means that we're trying to find this angle right here, which we'll call theta. So from here, what we know is that this side right here is the 11.52. And if we were to complete the triangle on this side, we know that this side is the same as this side. So we know that this side right here is, sorry, we know that this side is the 216.42 newtons. So we're trying to find this angle, and we know the opposite angle and the adjacent angle. So because of that, we're going to be using tangent, since tangent is opposite over adjacent. So we're going to write out tangent theta is equal to opposite, which is the, sorry, yes, which is the 216.42 newtons over adjacent, which is the 11.52. And from there, we're just going to solve for theta. So theta is equal to the tangent inverse of 216.42 over 11.52. We plug that into our calculator. And that should give us that theta is 86.95 degrees counterclockwise from the positive x axis. And just like that, we were able to find the direction of our resultant force going counterclockwise from the positive x-axis. If it were to have asked us to find the direction of the resultant force going clockwise, from the positive x-axis, what we would do is, starting from the positive x-axis, once again, we would be going this way, so clockwise, until we hit that resultant force. And once again, that would be easy since we know that this angle right here is 90, this angle right here is 90, and this angle right here is 90. So that's a total of 270. And then from there, you would just have to find this angle and then add that to the 270. So just like that, we were able to find, to determine the magnitude of the resultant force and its direction for problem 2-40.